3 Anti-Laws of Indices, Part 2. Zero indices. Now what is a to the power of 5 divided by a to the power of 5? Now for our indices rule number 2, it tells us that if I have a to the power m divided by a to the power n, it will be a to the power of m minus n. So if I were to have a to the power of 5 divided by a to the power of 5, this is technically a to the power of 5 minus 5, which gives me a to the power of 0. But what exactly is the value for a to the power of 0? Now let's take a look at a to the power of 5 divided by a to the power of 5. It can be written as a fraction, a to the power of 5 over a to the power of 5, which means we will have a times a times a, how many times? 5 times in the numerator, and a times a 5 times in the denominator. Now when we have fractions, we will need to simplify the fraction by cancelling out common factors. So in this case, I'll cancel out one pair of factor a. After I divide by a divided by a will give you not 0 but 1. So I'll cancel out, I'll get 1. So after cancelling all the factors out, what am I left with? I'm left with 1 over 1, which is the value 1. So therefore, the zero index rule says anything to the power of 0 will be equals to 1. Negative indices. Now what is a to the power of 5 divided by a to the power of 6? Now indices rule 2 says this is a to the power of m. When there's division, what do we do to the power? We subtract the power. And if that's the case, a to the power of 5 divided by a to the power of 6 will give me a to the power of 5 minus 6, which becomes a to the power of negative 1. Now what exactly is a to the power of negative 1? Let us take a look. I can write a to the power of 5 divided by a to the power of 6 as a to the power of 5 over a to the power of 6. And this can be written as a times a all the way 5 times. And this will be a to the power of 6, so it will be 6 times. So now when we have fraction, I'll need to cancel out the common factors. Dividing both by a, it will give me 1, not 0. 1. And I'm left with one of the a in the denominator. Okay, so if this is the case, this is actually now the numerator left with only 1, the denominator left with only a, so this will be 1 over a. So in this case, the negative index rule will be a to the power of negative 1 will means it is 1 over a. So now we know that the negative indices, okay, is a to the power of negative 1 is 1 over a. Okay, we can use this on other types of questions. For example, a to the power of 5 divided by 6 is a to the power of 5 minus 6, which is a to the power of minus 1. I can rewrite it as 1 over a, where this is the negative index form. And this one over here, you notice the power for a is positive. This is the positive index form. Okay. Now what happens if I have a to the power of 5 divided by a to the power of 8? This, if I'll go by my indices rule, this will be a to the power of 5 minus a to the power 8. So I'll get a to the power of negative 3. On the other hand, if I were to write this as a fraction, a to the power of 5 over a to the power of 8, it will be a times a five one, two, three, four, five, six, seven, eight. 8 of them, and we will be able to cancel. We will have 1 over a to the power of 3. So what does this tell us? If I were to compare this, I'll have a to the power negative 3 to be equivalent to 1 over a to the power of 3. What is the effect of the negative sign? The negative sign is actually similar to writing the whole indices as 1 over. But then the power here, 3, stays the same. It does not change. So it follows the A. So if that's the case, for example, if I were to look at what is a to the power of negative 5, it will be the negative power will give us 1 over, and a itself has the power 5, so it'll be a to the power of 5, where this is the negative index form and this one over here is the positive index form. Both of them are the same. Now, some of the questions may require us to write the original number from the negative index form into the positive index form. How do we do that? So in this case, if I'll have 5 to the power negative 1, this actually means the negative power is 1 over. And the number 5 itself is the base with the power 1, so it's just 5 to the power 1. Alternatively, we can also see this as 5 over 1, the whole thing power negative 1. Then when I switch it to positive index form, from 5 over 1, it will swap to become 1 over 5, and the power will be from negative to become positive. Now let us consider the next type of question. This is a very common mistake that students will make. Now for this question itself, some of you will write it as 1 over 3x, but actually that is wrong. Why is that so? Because the negative power 1 is only for which letter? It is only for x. It is not for 3. So if I were to write this, I can write this as 3 times x to the power of negative 1. That gives me 3 does not have a negative power, so it stays as 3. And when I need to multiply by x to the power of negative 1, now I will take this to be x over 1, and I will swap the thing to become 1 over x. And this gives me 3 is in the numerator, So this will be 3 over x. Please do not write as 1 over 3x. Okay, now next type of question. What happens if we have a fraction and there is a negative power? Now this fraction is for, negative power is for the whole fraction. In this case, what we'll do, we will need to swap our fraction and it will become x over 2. The whole thing needs to swap. But the power now becomes from -1 becomes +1. Let's look at more examples. For example, if I have the negative index form 3x over y whole thing to the power -2, what we need to do first is to get rid of the negative power. So what do I need to do? I need to swap the fraction, and that will give me y over 3x. The whole thing from the power -2, it will become +2. Next, I'll need to apply this power to every term inside the bracket. So it will become y squared 3 squared x squared, which is, I need to simplify the number 3 squared. 3 squared is actually 3 times 3, which is 9. So this will be y squared over 9x squared. One more example. 2 over x whole thing to the power of -3. What do we need to do? We need to swap the fraction. So this case, I will get x over 2, the whole thing to the power of +3. Notice it has changed from negative power to a positive power. Now I need to apply power 3 to every single term inside the bracket. I will get x cubed over 2 cubed. Now let us simplify 2 cubed. 2 times 2 times 2 is 8. It is not 6. So this will be x to the power 3 over 8. Then this is how we convert from the negative index form into the positive index form. Now another application of the zero and negative index rule is, for example, find without using a calculator the value of 3 bracket 5 to the power of 0 plus 4 to the power of -1. Let us recall our zero index rule. It says a to the power of 0 is equals to 1. And if I have a to the power of -1, it is equals to 1 over a. So now let's take a look at our question. What is this? This is actually 3 times 5 to the power of 0 plus 4 to the power of -1. Applying the zero index rule for 5 to the power of 0, take note 3 does not have power 0, so 3 stays the same. And 5 to the power of 0 becomes 1. And 4 to the power of -1 becomes 1 over 4. Simplifying, we will get 3 plus 1/4, which gives us 3 1/4.